Uh, Hi there. Today I'd like to discuss about the duality in consumption. Uh, Basically, what duality is and how does it come from, and the comparison between dual problem and the primal problem, and and what else we can get from the duality. So let's get started. Uh, If I could give a definition to the duality in consumer theory, so that will be the dual approach to the demand theory that is based on the fact that preferences can be represented in two forms other than the utility function. That means preference will be represented by two forms, that is not the utility function, that is other than the utility function, that is exactly uh, given in here. So these are expenditure function. We'll show that later on. And the other one is indirect utility function. So we also uh, we will also show how we can get the indirect utility function from the primal problem and expenditure function from the dual problem. So the uh, uh, main discussing thing here is dual problem. So uh, if we can relate, if we can give a definition of the uh, consumer theory, which entails the dual problem. So here it is. It came from the primal problem, which is the utility maximization problem. So we economists always try to maximize our utility, which is utility maximization problem, UMP. Is the so-called primal. So this is the primal problem. If this is primal, so its dual will be expenditure minimization problem. We always try to minimize our monetary values, our monetary terms, that is our income or expenditure. So it is EMP, expenditure minimization problem. So here the graphic shows graphic illustrates as an example, which is a turtle. So if we can present the turtle's distance traveled by t time, and the distance is x. So if we can figure it out in a graph, so we can see here mt is the function. So the turtle can travel x star distance by t star time. So if we can say that this x star is the solution to this turtle maximization, or distance maximization, or uh, time minimization problem. So only if and only if this empty function is monotonic and there is continuity, then x star could be the solution to this problem. Otherwise, if the function is non-monotonic, then this does not guarantee that there will be a solution to this problem. So as this is an example, the basic example, so the maximum distance that a turtle can travel in t star time is x star. So this is what we called primal problem. So its dual will be the minimum. So the minimal time that a turtle needs to travel x star distance is t star. That means travel distance will be x star, and this needs to be covered by time t star, that is the minimum time. So that is the dual problem. So I hope all you can get a basic idea about the dual problem and what is the primal problem. So it will be helpful for our consumer theory, because there is duality in consumption theory. And let's take a deep dive into the consumer theory. So if our budget is fixed, that is our money, and utility maximization is the target or our goal, then it is primal problem. And if our utility is fixed, that is utility given, and cost minimization is our target, so that is the expenditure minimization. So that will be the dual problem in consumer theory. That's the main idea uh, behind this duality in microeconomics, or even the consumer theory of microeconomics. Uh, so if we try to get the quantity demanded, or the quantity demanded from the demand function, where budget is given and utility maximization is our target. Similarly, we can get the quantity demand from the demand function, where utility is given and minimization is our goal, or our destination, mm, or whatever we can say. So uh, here I made a simple slide that illustrates primal problem and dual problem in two sides, so everyone can easily understand the subject to constraint and the maximization or minimization problem of primal and dual problem. So here, primal problem consists of maximization of utility function, whereas the subject to constraint is P x equals to M, where P is the price and X is the quantity of a good, and M is income. So this is the subject to constraint function. We need to maximize utility within that subject to constraint. And however, the dual problem is the minimization of the budget. So our budget is price times quantity. So that is Px. So this is the minimization problem. Whereas the constraint is subject to constraint is given utility, which is U bar. So from the primal problem, if we solve it, we can get Marshallian demand, which basically depends on the price and the money, which is our income. So this is Marshallian demand. Whereas from the dual problem, we can get Hicksian demand. Hicksian demand is basically depends on the price, similarly to Marshallian demand, but here it depends on utility, which is given. So it is the subject to constraint. So this demand functions, or we can say curves, are compensated, these two demand. So Marshallian demand, if we if we put some if we put our variables into the Marshallian demand, at the end we can get indirect utility function, which is in terms of price and money. So that will be our indirect utility function. And if we put the variables on the Hicksian demand, we can get the expenditure function, which will be the uh, function for the expenditure minimization problem, EMP. So it is in terms of price and given utility. So these are the two function and two demand we can get from the primal problem and dual problem. So this is the thing. And now if we uh, if we try to make an illustration or relationship between the Marshallian demand and Hicksian demand, we can use the Slutsky equation. We can use, or we must use the Slutsky equation basically, because it represents the relationship between these two demand function, Marshallian demand and Hicksian demand, whereas Slutsky equation represents the substitution effect and income effect. And these two effects are available, or these two effects are visible on these two demand functions, or these two in those two problems. So Slutsky equation is the instrument that represents the relationship between Marshallian demand and Hicksian demand. So Slutsky equation is an undergrad topic, uh, uh, and here we can also put this equation to represent the relationship between these two demand. So now here is the thing, that is, if we put indirect utility function u bar into this Hicksian demand where there is u bar, so we can get Marshallian demand. So this is a cross relationship actually. So we can get a demand function by putting the other utility function or other function into another demand function. So this is quite an interesting relationship. Similarly, if we put expenditure function into the Marshallian demand, so what can we get? We get Hicksian demand. So these are the basics actually. How can we get one function from another function by putting other functions? So these are the relationships, but these are critical relationships because remembering them might be tough because uh, there are chaos to remember them. Seem quite similar. All of them are quite similar. So uh, then uh, if we think about the differentiation, then that indirect utility function, if we differentiate Martian demand with respect to P, we'll get Roy's identity, which is very important for the grad studies. And if we uh, differentiate Hicksian demand with respect to given utility, we will get the Shepard's lemma, which is negative. So that's all for the dual problem and the primal problem, and what are the difference between them, and what can we get from these two problem. So that's all. Hope everyone will like it, and thank you so much.